The monosaccharides have functional groups that can undergo oxidation. Remember that reduction and oxidation are the opposite. So if I take this aldehyde functional group, I can oxidize it to a carboxylic acid. Taking the carboxylic acid to an aldehyde, that would be reduction. I can take this aldehyde and reduce it to an alcohol, and I can take the alcohol and oxidize it to an aldehyde. Well, let's look at one of these reactions. When I go from aldehyde to carboxylic acid, notice what happens. An oxygen gets inserted here on the carbon, and the carboxylic acid is formed. Remember, adding or gaining oxygen, which the carbon does there, is oxidation. If I take the carboxylic acid and change it to an aldehyde, that is through reduction. I'm removing oxygen. I can change the aldehyde to an alcohol by doing what? I add a hydrogen here and I add a hydrogen here. See this? There's an additional hydrogen down here and additional hydrogen there. The addition of hydrogen is reduction. The removal of hydrogen would be oxidation. Well, when we consume glucose has an aldehyde functional group on it. It's an aldohexose. And that what your body does to metabolize it is it will oxidize it, and then it's able to process it further. If I look at an aldehyde, we will reduce them to alcohols and use those in sugar-free candies because sugar alcohols aren't absorbed into your bloodstream, and so it can't raise your blood sugar. This process is really important when we look at ethanol. This is ethanol right here. When we drink ethanol, ethanol is a nerve toxin. If you drink enough of it, you will sedate your nerves, and then if you drink enough, you will cause them to quit, and you can actually stop your breathing and stop your heart from beating due to too much ethanol sedating those nerves. Ethanol, because your body recognizes it as a toxin, has to be metabolized or somehow gotten rid of. You exhale a little bit in your breath, but the majority of your ethanol is gotten rid of from your body by oxidation. The way that your body does is it takes ethanol and it oxidizes it to acetaldehyde. That's a very fast step. There's a slow step of taking acetaldehyde and oxidizing it further to acetic acid, which then can go through the citric acid cycle. This step of going from acetaldehyde to acetic acid is slow relative to this step, so if someone consumes a lot of ethanol, they'll build up a significant quantity of acetaldehyde, and that's actually what causes the hangover feeling. Chitin is a modified it's a modified polysaccharide, meaning that it's not just plain monosaccharides linked together. Let's look and see what chitin is. Chitin is found in insects and the exoskeleton of insects and some crustaceans, and you have them in fungi. What is it? Well, it's glucose, but it's glucose that has been modified. The hydroxyl group that was down right here, notice this is beta, up. The number 2 carbon has a hydroxyl group that has a nitrogen on it and then an acetate attached to that. That's why it's called N-acetylglucosamine. If you take the acetyl off, that's glucosamine, which you hear of being touted for helping with arthritic joints in your knees and such. And why? Because your collagen, your cartilage, is one of the building blocks for cartilage is glucosamine. Likewise, we have, this is the monomer that is the basis for the polymer polysaccharide chitin. And what it is a 1,4 linkage. So 1 to 4 linkage. And so you have a bunch of these all connected, 1,4 linkages. And it looks just like starch, except for this group added on instead of the hydroxyl. Oligosaccharides, remember oligosaccharides are just a few sugars, monosaccharides, attached to each other. There are oligosaccharides that determine what type of blood you have. If you have type O blood, you've got 3 monosaccharides attached together, right there. If it's type A, you've got 4 of them attached together. Type B, there's 4. And you can see they're very similar, but they're slight modifications. But that slight modification is what would cause an immune response if you had the wrong type blood given to you. Heparin is a drug that we give to prevent clotting. It is a polysaccharide. The repeating unit that you see in this polysaccharide is a sugar right here. And just like glucosamine, there's a nitrogen here, but attached to that then is a sulfate group. And on the alcohol group up here, it's been substituted with a sulfate group. There's another monosaccharide there that is, instead of an alcohol group, it's a sulfate group. And notice, this carbon, which was up, this one's down, it has been oxidized down all the way to a carboxylic acid. It's not showing you with the hydrogen after it, but that is the salt of a carboxylic acid. So we see these polysaccharides or monosaccharides in various places in the body and in other parts of biology.